For billions of years, the universe has been a grand factory, recycling the same matter over and over again. Every star we see in the night sky today is a polluted star, containing the chemical ashes of previous generations that lived and died long ago. But astronomers have long hunted for a holy grail, a star so old that it was born almost immediately after the Big Bang, a survivor from the very dawn of time. In recent years, they found it. This is the story of SMSSJ031300, 36 to 670,839 a star located right here in our own Milky Way that has been shining for a staggering 13.6 billion years. It is the most ancient star ever discovered, a celestial time capsule that holds the secrets of how the first lights in the universe were turned on. To understand why this star is so important, we have to look back at the dark ages of the universe. In the first few 100 million years after the Big Bang, there were no stars. The universe was filled only with the lightest elements: hydrogen, helium, and a tiny trace of lithium. There was no carbon for life, no iron for planet cores, and no oxygen for water. These heavier elements, which astronomers call metals, had not been created yet. The very first stars, known as population 3 stars, were born from this pristine gas. They were monsters hundreds of times more massive than our sun, burning with a brilliant blue-white ferocity. Because they were so large, they lived for only a few million years before exploding as supernova. It was inside these first explosions that the very first metals were forged and scattered into the void. The star SMSSJ 031300 is what astronomers call a population 2 star. It wasn't the very first star ever made, but it was likely the second generation. It formed from a cloud of gas that had been seeded by the explosion of just one single population 3 star. We know this because of its chemical fingerprint. When astronomers use a technique called spectroscopy to analyze the light of a star, they can see which elements are inside it. Most stars, like our sun, are rich in metals because they have been recycled through many generations of star death. But SMSSJ 031300 is incredibly pure. It has a level of iron so low that it is almost immeasurable, less than 1/10,000,000th of the iron found in the sun. This tells us that when this star was born, the universe was still almost entirely made of hydrogen and helium. It is a direct descendant of the first stars to ever exist. The discovery of this star challenged our understanding of how the first stars died. For a long time, we thought the first stars exploded with such violence that they blasted all their heavy elements far into space. But the chemistry of SMSSJ 031300 suggests something different. It contains a tiny bit of carbon, but almost no iron. This implies that the parent star that came before it died in a relatively low-energy supernova. The explosion was strong enough to push out the lighter elements like carbon, but the heavy iron core of the parent star was sucked back into a black hole or a neutron star. This discovery gives us a much clearer picture of the cosmic dawn, showing that the first generation of star death was more complex than a simple, massive blast. You might expect the oldest star in the universe to be in a galaxy billions of light years away, visible only to the James Webb Space Telescope. But SMSSJ 031300 is right here in the Milky Way, located about 6,000 light-years from Earth. It is a red giant star, meaning it is in the final stages of its long life. How did it get here? In the early universe, small protogalaxies were the first to form. As gravity pulled these small clumps together to build the massive Milky Way we see today, the ancient stars they contained were mixed into our galactic halo. This star has been a silent witness to the entire history of our galaxy. It watched as the Milky Way devoured other galaxies, as the Sun was born and as life emerged on Earth. It is a piece of the deep past living in our modern neighborhood. Finding the oldest star isn't just about breaking records. It is about understanding our cosmic genealogy. By studying the composition of SMSSJO 31300, we are learning about the environment of the early universe. We are seeing the transition from a universe of simple gas to a universe of complex chemistry. This star is a reminder that we are part of a continuous chain of events. The carbon in your DNA was forged in stars just like the one that seeded SMSSJO 31300. By looking at this ancient light, we are looking at the prehistory of our own atoms. It bridges the gap between the Big Bang and the world we see today. While SMSSJO 31300 currently holds the title of the star with the lowest iron content, the hunt continues. Astronomers are using the SkyMapper telescope in Australia and other deep sky surveys to scan millions of stars in the Milky Way's halo, looking for even purer relics. Every new discovery of an ultra-metal-poor star is like finding a new page in a history book that was previously thought to be lost forever. With the advent of the extremely large telescopes currently under construction, we may eventually be able to see the first stars themselves, the population 3 giants as they existed 13.5 billion years ago. Until then, stars like SMSSJO 31300 are our best proxies, the surviving elders of the cosmos who tell the story of the first light. The most ancient star ever discovered is a testament to the longevity of light. For over 13.6 billion years, this star has been burning its fuel, sending its photons out into the expanding universe. Some of those photons traveled through the void for thousands of years, finally landing on a mirror on a hill in Australia, allowing us to reconstruct the beginning of time. It is a humbling thought. While civilizations have risen and fallen on Earth, while mountains have crumbled and oceans have shifted, this single star has remained virtually unchanged. It is a survivor of the greatest era of transition in history. As it slowly exhausts its remaining fuel and prepares to fade away, it leaves behind a legacy of knowledge, a final gift from the dawn of time to the curious species that finally learned how to listen to its light.